Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 4, that is Measures of Dispersion, brought to you by Vitan Sir. In my last tutorial, which was also the first one for this chapter of Measures of Dispersion, we discussed what is dispersion, the four measures of dispersion, and we also understood range and completed exercise 4.1. Okay, we did quite a lot of things for the first tutorial of the chapter. Now this is the second tutorial for the chapter, and this tutorial I'm going to start, explain and complete exercise 4.2 regarding the second measure of dispersion, that is quartile deviation. Now, what is quartile deviation? We have heard the word quartile in the previous chapter. Quartiles divide our distribution into four equal parts. There are three quartiles: Q1, Q2, Q3. Q2 itself is the median, which is the middlemost value. The first 25% observations are Q1 and the last 25% observations are the Q3. So this is the basics of quartile. Now we have to calculate this deviation. Now this deviation, the measure of variation, which is defined by using the middle 50% of the observations. Now when I talk about middle 50%, it means Q1 to Q3 arranged in ascending order is called quartile deviation. It is denoted by QD. Q, that is quartile, and small d, that is deviation. So what we are going to use in the calculation of this measure of dispersion is the first and the third quartiles. So first and the third quartiles are the two extreme of the quartiles, first being the 25%, second being the last 25%, and we are going to use that measure to calculate the dispersion of the data. Now the absolute QD, that is the basic measure, is the average here, Q3 minus Q1 divided by 2. So it is kind of a special average where we find the difference of the first and the third quartiles and we divide that difference by 2. So that way we can actually see if median is at the exact center of this distribution, or this distribution is distributed equally, or if there is no dispersion, then of course we are going to get the answer 0, because there will not be a kind of a difference there. But if this distribution has a huge dispersion, then the answer will be bigger and bigger and bigger. Let's see what happens afterwards. This quartile deviation has a second name known as semi-interquartile range, because it is also a kind of a range. What we used to do in range is difference between the highest and the lowest observation. In quartile deviation, we are finding difference between the highest and the lowest quartiles. So it is kind of a range, but range between the quartiles. So it's known as the semi-interquartile range because we are dividing it by 2. If it would not be divided by 2, just the difference, it would be interquartile range, but because we are dividing it by 2, we call it semi interquartile range. Okay, so it's a range consisting of average of the difference between the quartiles. Next, the relative quartile deviation, that is Q3 minus Q1 divided by Q3 plus Q1. Okay, this is something similar to how the relative range we calculated, where highest minus lowest divided by highest plus lowest was that. So this is again the same thing, Q3 minus Q1 divided by Q3 plus Q1. That's going to be our formula for relative QD, which is also known, the relative quartile deviation is also known as coefficient of quartile deviation. Now this is becoming a pretty standard thing. The regular value is known as range or quartile deviation or mean deviation and standard deviation, and its relative will be known by adding a word coefficient. Coefficient of range, coefficient of quartile deviation, in the future coefficient of mean deviation and coefficient of standard deviation. It would be something like that. So quartile deviation shows the average value by which two quartiles differ from the median. Hence this dispersion depends on the quartiles and median value. So if we take an average of Q3 and Q1 and we get the exact answer as median, then okay, there is no dispersion. But if we find the answer and that answer differs from the median value, that means there is some kind of a dispersion. But my dear friends, don't use that much of a brain. You are still in 11th, so just try to calculate this measure. In the future years, we will discuss how it can be practically applied. So leave it at future. Right now, just concentrate on learning the formula and solving the sums. Actually, before we start with solving the sums, let's see the advantages and disadvantages of the quartile deviation. Starting with the advantages. So it is very clearly defined. Okay, it's simple. Middle 50% observations are used in its deviation. So that's simple. We are not going to do anything else. Clearly defined. Its computation is also relatively simple. You just need to calculate the first and the third quartiles, find the difference, divide it by 2. That's all. It is not affected by very small or very large observations, because very small observations will be in the below 25% observations, and very large observations will be in the top 25% observations, which we are not using. We are only using the middle 50% observations. That means too large or too small observations are not going to affect our calculation. It is the only measure of dispersion which can be computed for distributions with open-ended classes. That means if any distribution has open-ended classes, then quartile deviation is the only possible measure to be used. Now going to the disadvantages of quartile deviation. Now for that, the first and last 25% observations are ignored. Hence all observations are not used in its calculation, and we know that the measure which does not use all the observation is that much less accurate. So quartile deviation is a bit less accurate than the future measures which we will study. It is not suitable for further algebraic calculations. Quartile deviation is not actually used for a higher study of statistics. It is not a stable measure, and it is less applicable in advanced study of statistics. That means in future you are not going to use range, you are not going to use quartile deviation. But right now we have to learn it because these are some basic values. Let's move forward with the exercise. Previously we have completed exercise 4.1, so now this is going to be the time for the exercise 4.2. First question. A shooter missed his targets in the last 10 trials by the following distances. During practice sessions, find QD and its coefficient for the distance missed by shooter. Okay, now we have the data 20, 32, 24, 41, 18, 27, 15, 36, 35 and 25. So there is a 10 value. There are 10 values, 10 observations. We have to arrange these observations in ascending order because we are calculating the quartiles. And in the calculation of quartile, we always need to arrange them into ascending order. Then only we can find the values. So ascending order is 15, 18, 20, 24, 25, 27, 32, 35, 36 and 41. Now we know that he has tried for 10 times, so 10 observations are there, and we need the first and the third quartiles using the raw data method. Okay, now I hope you guys do remember the third chapter. If not, just go back to that and start revising it. Okay, so starting with the quartile, that is Q1. The value of 10 plus 1 upon 4th observation, because it's a raw data or a discrete data, plus 1 is to be added into our total outcomes, that is 10. So that will get you to 2.75th observation. Now 2.75th observation lies between second and the third observation here. So we have to use that formula, second observation plus 0.75 into bracket, third observation minus second observation. Now second observation is 18.75, third observation is 20, and again second observation is 18. So 20 minus 18 will be 2, which we will multiply with 0.75 plus first. That would be 18 plus 1.5, and your first quartile will be 19.5 millimeters, that is mm. Next we have to calculate the third quartile, that is Q3. That would be value of 3 multiplied by 10 plus 1 upon 4th observation. So accordingly your answer will be the value of 8.25th observation. Now 8.25th observation is between 8th observation and the 9th observation. So 8th observation plus 0.25 into brackets 9th observation minus 8th observation. Now 8th observation here is 35 and ninth observation is 36. So 36 minus 35 is 1. So 0.25 into 1 is just 0.25. Add 35 into it and you get 35.25 mm. Now we are going to use both of these values in our calculation of quartile deviation and coefficient of quartile deviation. Starting with the quartile deviation first, absolute QD is Q3 minus Q1 upon 2. Now Q3 is 35.25 and Q1 is 19.5. So first find the difference and then divide it and then simplify it. So you will get 7.88 mm. So the quartile deviation for your data is 7.88 millimeters. Because it's a absolute measure, we have to show the unit of measurement millimeters in the answer. But in the coefficient of quartile deviation, we are not going to do that because coefficients, the relative measure, is free from such units. So relative QD will be Q3 minus Q1 upon Q3 plus Q1. So you have to put the value that 35.25 minus 19.5 divided by 35.25 plus 19.5. And you will see that you get 15.75 upon 54.75. When you divide it, you get 0.2877. Rounding off will get 0.29 without any unit of measurement in the answer. So the quartile deviation is 7.88 mm and the coefficient of quartile deviation is 0.29. Moving on to the second question of the exercise. Find quartile deviation and coefficient of quartile deviation of the marks from following. Okay. So from the following data, we have to find quartile deviation and the coefficient of quartile deviation. Now, this is basically a longer question, but I have shortened the question because table I have already shown here. Marks, number of students, marks are 10, 20, 30, 40, 50, 60, and number of students 4, 7, 15, 8, 7, and 2. So from the data, we can see that the data is a discrete frequency distribution, and for calculating any frequency distribution, I will need a cumulative frequency uh, row. So CF row I am going to create here. Cumulative frequency, how do we calculate? The first frequency is 4, so it will be as it is. Add 7 into 4, it will be 11. Then add 15 into 11, 26 plus 8, 34 plus 7, 41 plus 2, 43. So total number of students are 43. That's my CF row. Because this is a discrete distribution, I start with my calculation of quartile, that is Q1, as the value of 43 plus 1 upon 4th observation. Now 43 plus 1, because it's a discrete distribution, still I have to add 1. That would be 44 upon 4, that is 11th observation. Now this time I have to find this 11th observation in my CF row. If you can see here, the 11th observation falls under the CF 11 itself. Okay, so from CF 11th observation lies in the CF 11, and in front of that CF 11, if you check the marks, there are 20 marks. Okay, in front of 11th CF, the value in the marks row is 20. That means my first quartile here will be 20. Similarly, if I calculate my third quartile, the value of 43 plus 1 upon 4 into 3 observation. So 3, when you multiply it, you get the 33rd observation. And that way, 33rd observation you can see in the 34th CF, and the 34th CF, the marks in front of 34th CF is 40 marks, and because it's the 40 marks, my third quartile will be 40. Now I start with my absolute QD, that is quartile deviation, Q3 minus Q1 upon 2, that would be 40 minus 20 upon 2, that is 20 upon 2, 10 marks. Because this is a quartile deviation, I have to put the unit of measurement, that is marks, in the answer. Next, relative quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1. The answer here will be 40 minus 20 upon 40 plus 20. That is 20 upon 60, that is 0.33. Now in 0.33, I don't need to put any unit of measurement because this is coefficient of quartile deviation. So your quartile deviation would be 10 marks and coefficient of quartile deviation will be 0.33. Moving on to the third question of the exercise. Third and the final question of the exercise as well as this tutorial. Find quartile deviation and coefficient of quartile deviation of the amount from the following information. Now in the table you can see the amount in rupees is given and number of customers is frequency, and the data is given in the classes here: 0 to 50, 50 to 100, 100 to 150, up to 200 to 250. Frequency 25, 40, 80, 30 and 25. The total frequency 200 is given in the sum. What we need to do is start with the cumulative frequency row as usually. Now first frequency 25, add 40, 65, add 80, 145, add 30, 175 and add 25, that would be 200. Now because this is a continuous distribution, I can't directly calculate the quartile here. First I need to identify the quartile class, and then using the data of the class and the lower limit and the frequency and the previous cumulative frequency and the class length, I need to calculate that quartile value. So this is going to be a little bit longer equation than the previous two sums. We have to start with the first quartile class here. Because this is a continuous distribution, we don't add 1, so it is just a class of 200 upon 4th observation, that would be 50th observation here. And from the CF you can see that 50th observation falls under the CF 65, and 65 CF is in the class of 50 to 100. So from CF 50th observation lies in the class 50 to 100. Now using this data we need to identify our lower limit, which is 50, frequency which is 40, the previous CF which is 25, and the class length which is 50. So L is 50, F is 40, CF is 25, C is 50. We need to put the formula, that is Q1 is equal to L plus N upon 4 minus CF upon F into C. In case you have forgotten, you can just refer to my third chapter videos of the quartiles. You will find them in my titles in the playlist in which this video belongs. Because the formula is written, I will put the values in that formula here. Q1 is equal to 50 plus 50 minus 25 upon 40 into 50. Now 50 minus 25 upon 40 into 50, I will simplify that first. So 50 plus 31.25 will be the answer, and therefore my first quartile value will be 81.25 rupees. That's my first quartile. Next, moving on to the third quartile class, that would be class of 3 into 200 upon 4th observation, and that would be 150th observation. Now from the CF you can see that 150 falls under the CF 175, and 175 is in front of the class 150 to 200. So my 150th observation lies in the class 150 to 200. So my lower limit here will be 150, the frequency 30, the CF 145 and the class length 50. Putting these values in my formula of Q3, that is L plus 3n upon 4 minus CF upon F into C, I get Q3 is equal to 150 plus 150 minus 145 upon 30 into 50. Simplifying the second part of this equation, I get 150 plus 8.33, and thus my third quartile will be 158.33 rupees. Now I'm going to use Q1 and Q3 to calculate my quartile deviation and the coefficient of quartile deviation. Starting with the quartile deviation here, absolute QD is Q3 minus Q1 upon 2, that is 158.33 minus 81.25 divided by 2. The difference is 77.08 divided by 2, that is 38.54 rupees. Because this is a quartile deviation, the absolute measure, I have to put the unit of measurement, that is rupees, sign in there. But when I calculate coefficient, I don't need to put that unit sign in there. So relative QD will be Q3 minus Q1 upon Q3 plus Q1. That is 158.33 minus 81.25 divided by 158.33 plus 81.25. And when you simplify the numerator and denominator, you get 77.08 divided by 239.58. And when you divide them, you get 0.3217. And simplifying it will get you the answer 0.32. So the quartile deviation for the given distribution or the given data is 38.54 rupees, and coefficient of quartile deviation is 0.32. We don't need anything extra right now. In the future we will learn how to interpret this kind of situations, but that's for the future. So with this I end my today's tutorial. I have completed the quartile deviation and the exercise 4.2. Study these things properly. There are certain illustrations, you can study those illustrations on your own for the self practice using these calculations as the basis, because the answers of illustrations are already given in the textbooks. I am not doing them or repeating them here. So I am only solving the exercises. If you like what I am explaining, give me some comments. You can put some suggestions. You can like this video. Please like this video, subscribe the button if you have not yet, and share it with your friends. And I will see you next time with the third measure of dispersion, that is the mean deviation. See you then, and thank you. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.